Hello guys, my name is Prajwal Rao D. I'm studying in first year of computer science in Sri Venkateswara College of Engineering in Bangalore. So my topic is to talk about the lasers and optical fibers. Yeah, I'm going to give an outlook or make you guys understand better about this module in this video. So let's not waste time and start the module. Introduction to lasers. Lasers, or light amplification by stimulated emission of radiation, produce highly focused beam of light. So when I talk about lasers, when I talk about the lasers, an acronym for light amplification by stimulated emission of radiation, generate highly concentrated beams. They are characterized by their coherence, monochromaticity, directionality. So when I talk about the coherence, all the coherence is simple. Like all the light waves are in one phase, and the monochromaticity. The monochromaticity is emission of light at a single wavelength, and directionality. The directionality. The light travels in a focused and narrow beam. Lasers have applications in various fields, including medicine, telecommunications, and manufacturing. So about the applications, I'll talk in detail in the coming slides. So now let's talk about the types of lasers. There are several types of lasers, including solid state, gas, dye, and semiconductor lasers. So when I talk about the solid state lasers, solid state lasers use a solid medium like crystals. For example, ruby crystals. Uh, there are also ruby lasers. So in ruby lasers, the ruby is used as a solid medium for the light to emit. And gas lasers. Gas lasers use gases like helium neon. So helium neon, there is actually helium neon lasers and dye lasers. In these lasers they use organic dyes as a medium, offering tunable wavelengths. Each type of lasers has unique properties and is suited for specific applications. For example, semiconductor lasers are commonly used in optical communication. So when I talk about the semiconductor lasers, yeah, semiconductor lasers are compact and efficient. That's why they are commonly used in optical communication systems. So now let's talk about the working principle of the lasers. Lasers work by exciting atoms or molecules, causing them to emit photons. These photons are then amplified through a process called emission. And the result is powerful and the coherent beam of the light that can be focused and directed. So, the operation of lasers involves three main steps. Excitations. Excitation, atoms or molecules are energized to a higher energy state. And the second step is stimulated emission. So, in stimulated emission, excited particles release photons when triggered by the excited photons. And the third step is amplification. Okay, the emitted photons are then amplified as they pass through the medium, creating a coherent beam of light. So this was about the lasers, and I'll talk about the applications in the further slides. Now let's talk about the introduction to optical fibers. Optical fibers are thin strands of glass or plastic that transmit signals over long distance. So optical fibers are hair-thin strands of glass or plastic designed to transmit light over long distances. So they rely on the principle of total internal reflections to guide the light when within the core. So the working principle is the light is guided through a core by total internal reflection, minimizing the loss of the light. So optical fibers are widely used in telecommunications and internet connectivity and medical instruments. So yeah, I'm going to talk about the applications of the lasers and the optical fibers collectively in the next slides. So now let's talk about the types of optical fiber. So there are two main types of optical fibers. single mode and multi-mode fibers. Single mode fibers have a smaller core diameter and allow only one light mode to propagate. So single mode fibers have a smaller core diameter, like 8 to 10 microns, and these suppose only single light mode, uh, ideal for long distance communications. Okay, and the other thing is multi-mode fibers. So multi-mode fibers have a larger core and can carry multiple light modes, making them to suitable for shorter distance. So larger core in the sense, this has a diameter of 50 to 100 microns. This can carry multiple light modes, suitable for short distance applications. And now let's talk about the advantages of optical fibers. Optical fibers offer higher bandwidth and data transmission rates compared to the traditional copper cables. High bandwidth. So high bandwidth supports greater data transmission rate compared to copper cables. They are immune to electromagnetic interference, ensuring the stable signal. So now when we talk about the immunity to the electromagnetic interference, they ensure the signal stability. And additionally, optical fibers are light and more flexible, making them installation easier and making the installation easier and more cost efficient. So lightweight and flexible. When it is lightweight and flexible, it is easy to install or to maintain. And when I talk about the cost efficiency, these cost efficiency reduce operational cost over time due to minimal the signal degradation. So applications, yeah. Now I'm going to talk about the applications of the lasers. So lasers are extensively used in medical procedures such as surgery and eye treatments. So they play a vital role in industries and industrial applications, including cutting, welding, and engraving medicals. So in the industrial application, it's just material processing. I mean, not just a material processing, but it, it plays a vital role in industry also by cutting, welding, and engraving materials. So lasers are essential in research and development, particularly in spectroscopy and photonics. Now let's move on to applications of optical fibers. So, optical fibers are crucial for high-speed internet and telecommunication for system. So, when I talk about the telecommunication system, and these optical fibers are the backbone of the high-speed internet and the data networks. So, medical instruments. Okay, they are used in medical instruments such as endoscopes for minimally invasive surgeries. Medical instruments, these optical fibers are the key component in endoscopes for diagnostics and minimally invasive surgeries. Furthermore, optical fibers are employed in sensors for monitoring environmental condition and structural integrity. So sensors are deployed in environmental monitoring and structural health assessment. So, future trends in lasers and optical fibers. Advancement in laser technology are leading to more efficient and compact laser systems. The development of the optical fibers with improved performance is enabling faster data transmissions. Emerging technologies like quantum communications and integrated photonics hold great promise for the future. So, this was my video, and I hope I made you understand better in this video about the lasers and the optical fibers. Thank you so much.